In order to raise the curtains on applied problems on the normal distribution, we begin with the first example. In this example, we are told that the number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is approximately normally distributed with a mean of 1262 chips and a standard deviation of 118 chips, according to a study by cadets of the U.S. Air Force Academy. Question A. What is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips inclusive? So we begin with the concept. First, since it's a normally distributed random variable with a mean of 1262 and a standard deviation of 118 chips, I can represent the distribution as having a bell-shaped distribution. So you have 1262 here. The standard deviation is 118, and I'm interested in the probability between 1,000 and 1,400 chocolate chips. So 1,000 will be somewhere here. 1,400 will be somewhere here. So I'm going to shade the required region, and this is the probability between 1,000 and 1,400. And this is a good time to go to StatCrunch. So I'm going to take the parameters 1262 and 118 in. So here I am in StatCrunch. I have the parameters specified. The mean is 1262 and the standard deviation is 118. Just to be sure, let's check that again, 1262 and 118. And I'm interested in the region between 1,000 and 1,400. So going back to StatCrunch, I make sure I am having the right interface between, okay, let's see, between 1,000 and 1,400, and I will compute that. This is 0.8657. So taking that back to the working board, this will be equal to 0.8657. With that question completed, we move on to question B. What is the probability that a randomly selected 18-ounce bag of Chips Ahoy contains fewer than 1,000 chocolate chips? So again, I have my normal distribution and the center value, and I want to locate 1,000, and I'm interested in the region fewer than 1,000. It is the region below 1,000. So in this case, this is probability of x less than 1,000. And this will be equal to, going to StatCrunch, I would need the standard interface. I still have the right parameters, and I'm going to delete this, and I'm going to delete that too. Okay, and I want, based on the question, to the left or less than, in that direction. So I want less than or equal to 1,000 and compute. So this is 0.0132. Okay, so this is 0.0132 to 4 decimal places. With that question completed, we proceed to question C. In question C, we want the proportion of the bags that contains more than 1,200 chocolate chips. So, okay, let's do that again. All right, and so we have this piece. You have 1262. Now locate 1,200. That should be somewhere here. And I want more than. So that will be the area to the right of 1,200. And this will be probability of x more than 1,200. And this will be equal to, let's see, going back to StatCrunch, you want more than 1200 and hit this. So you have 0.7004. So this is 0.7004. Then for the next question D, what proportion contains fewer than 1125 chocolate chips? So I'll draw my normal distribution, locate 1262, and I want 1125. So this is 1125 here. And I want the region fewer than, so that would be the region to the left, lesser than 1125. So that would be probability of x less than 1125. I will go to start crunch, and I want lesser than this 1125 and hit the compute button. So you have 0.1128. So taking that back, 0.1128. Just to be sure, 0.1228 rather. 1228. And for the next question, what is the percentile rank of a 18-ounce bag of Chip Ahoy that contains 1475 chocolate chips? Since we're talking about percentile rank, this is what we do. Draw the normal distribution curve, locate the center, and we want to locate this value, which is 1475. That is a number above the median or the mean, which is 1475. And since we're talking about percentile, percentile always concerns the region equal to that value or lesser than that value. So in particular, we would like to find the probability of x less than 1475, and that will be, going back to start crunch, I'm simply going to change this to what the question requires, 1475. So 1475 and compute. This is 0.9645. Okay, so 0.9645. For the percentile, I would convert or multiply this by 100%. This gives about 96.45%. So I would approximate this to about 76%, or depending on what the question requires. Then the last question is a very similar one. What percentile rank of an 18-ounce bag of Chips Ahoy contains 1050 chocolate chips? You're welcome to pause the video at this point in time and see if you can follow this example to complete this example we're currently working on. For me, I am ready. So I will do this. I will put the center value there, and I'll locate 1050. 1050 should be somewhere here. And since we're talking about percentile rank, that always concerns equal that value or below that value. So this will be probability x less than 1050, and that will be equal to, going back to start crunch, so you have 1050 and compute. This is 0.0362. 0.0362, which if I multiply by 100% to get the percentile rank, this will give me about 3.62%. So I will say this is probably in the 4th percentile. Take note of what this means. This 4% means that about 4% of all of the 18-ounce bag of Chips Ahoy contain 1050 chocolate chips or less, or lesser than that. This is very important in the context of this problem. We proceed now to the next example. In this example, we are told that the lengths of human pregnancies are approximately normally distributed. So the variable of interest here is the length of human pregnancies, which we would denote with the placeholder x. And we're told that it is normally distributed. So we're going to need the mean. The mean is 266 and the standard deviation is 16. Question A. What proportion of the pregnancies last more than 270 days? So we have this piece, we have that. I will locate the center, 266, and I would like to locate 270. And I'm interested in the proportion of pregnancies that last more than this number of days. So that will be the area to the right. So proportion that lasts more than 270 days. In this case, I will go back to start crunch. I need to put in these parameters. So 266 and 16. So 266 and 16. And I'm interested, of course, based on the interpretation of the problem, greater than or equal to 270. So greater than or equal to 270. Enter 0.4013. So this is equal to 0.4013. This is the proportion of pregnancies that last more than 270 days. Then, with that said, we proceed to question B. What proportion lasts less than 250 days? So we have this piece, we locate 266, and then we locate 250. We want to find the area less than 250 days. So in this context, this is probability of x less than 250, and that will be going to start crunch. I want less than or equal to 250. Enter. That is 0.1587. 0.1587. Question C. What proportion of pregnancies last between 240 and 280 days? So I have this. I have the center, 266. I'm going to locate 240. I'm going to locate 280 approximately. And I'm going to shade between. And I'm interested in the probability between 240 and 280. This will be equal to, let's see, going to start crunch. I'm going to change to the between interface, and I want between 240 and 280. So let's do that. Between 240 and 280. Compute, you have 0.7571. Okay, so 0.7571. Then for the next question, D, what is the probability that a randomly selected pregnancy lasts more than 280 days? Based on the Bayes distribution, you have 266 here. And for more than 280 days, I will locate 280. I'm interested in the area more than. And so in this case, this is probability of x more than 280 days. This will be equal to, going back, I need the standard interface. And I'm going to indicate more than 280 days and hit the enter button. You have 0.1908. 0.1908. And with that said, we proceed to question E. What is the probability that a randomly selected pregnancy lasts no more than 245 days? So I'm going to draw 266, the normal distribution, and then indicate the mean. Now I want the region that lasts no more than 245 days. So I will locate 245. What is the region no more than 245 days? That will be the region where the greatest value is 245. That would be from the 0.245 and below. So, with that said, I want probability of x less than or equal to 245, and this would be equal to, going back to StatCrunch, I want less than or equal to 245, enter. So you have 0 0.0947. 0 0.0947. Then question F. A very preterm baby is one whose gestation period or pregnancy period is less than 224 days. Are very preterm babies unusual? The steps here are as follows. Step 1, we're going to find the probability of a very preterm baby. Let's write this clearly. My pen is acting up. Probability of a very preterm baby. Yes, a very preterm baby. That will be the probability that gestation period or pregnancy period is less than 224 days. So that will be, looking at the probability, the distribution, you have 266. I will locate 224, and I want the region lesser than the value. So this will be equal to, going back to StatCrunch, 224. This is equal to 0 0.0043. Okay, so 0 0.0043. Then step 2 of this process is to answer if the occurrence of very preterm babies is an unusual event. In other words, we're going to check if this probability, let's check that, if this probability is less than 0.05 in the context of this problem. Well, since this probability, 0.043, is less than the threshold of 0.05 that we have adopted for this class, we claim that what? Very preterm babies are unusual. So with that said, we have answered all parts of this problem, and we will go to the next video.